going to talk about series that is a mouthful, which is shortened to an abbreviation, SBOM or C-SCRM. That's actually the name of a program at NIST, which I will talk about. Right? By the way, I'm Mostafa Moradian. You probably know me already. I have more than 20 years of experience in software engineering and security. I work at Grafana K6. I'm a senior software engineer and also security lead at K6. I work with these languages and probably more, and always learning. So if you want to reach out to me, those are the links. My default to join.
Or you have the
So this is the overview of what I'm going to talk about. So what are we dealing with today? So the problem statement, the framework that the NIST introduced, a few categorization of abstract tools. Then I'm gonna focus on software component analysis. I'm gonna talk about what is SBOM, how we can make use of it. Two different standards, SPDX or CycloneDX. So these are two standards of SBOM. And also I'll give you a demo, and then after that, QA. In between, also there's another demo, which I will show you a few different things before continuing my presentation. Okay, what are we dealing with today? These two general statements, I think, applies to literally everything. We have lack of visibility in everything. And what we want? Visibility and observability, visibility. We want to see, we want to observe so that we can make changes when things go wrong. Okay. And what are the processes we want to observe? And how do we want to observe decision making of developers? Okay, let me give an example. We are developing a software. We do, the waterfall, agile, whatever. And then at some point in time, usually at the beginning, we do some requirements engineering. We gather requirements, we deal with a few different things, we try a few different libraries, we try infrastructure code, this and that, and then we wrap our head around this project, we estimate time and other stuff. And at some point we decide, okay, I want to go with this. So we make a decision. Okay. But some companies, especially when they do agile, these decisions are so fastly made that sometimes they're not visible, they're not documented, they're nowhere. And suddenly you see that the code is published to production, and then eventually if you have some sort of security tool to scan your code, you see that, okay, this dependency that you're using has a vulnerability. But who introduced it? Who made the decision to use this open source vulnerability? And I'm going to talk about this today, actually, this visibility into decision making and processing. And also the next thing is we currently have a lack of comprehensive view to threats and vulnerabilities, mainly because it's sometimes hard for developers to accept things from security team, because usually they are disruptive. If you've ever worked with security personnel, they talk about things. Sometimes you say, hey, do you know what you're talking about? As a developer point of view, or not. But then, as I said, your code goes into production, everything goes into haywire. Like this. Okay? These are recent incidents that happened. So, if I can point it more. Sorry? Yeah, so everything is on fire. So this is published in 2021. This is a CVE for color.js. I don't know if you've heard about it. So the open source developer was kind of bored and said, okay, I no longer want to support these corporations using my code and not paying me anything. And they require me to update this part of code, that part of code. So let's mess with them. And he messed with all of us, like literally. He introduced some sort of code that broke CDK from AWS and a lot of other code. Yes, exactly.
What happened?
Illegal stuff. What happened?
Yeah, what happened? So it's an open source software. And if you've read those licenses on open source software, you take no liability for what you do. Yes, that's what I'm talking about, actually.
It doesn't really cover if you do it with malice, but sure.
Yes, but okay, we can talk into this. But
It doesn't have an asset, you won't get sued. So.
you won't get sued because then at some point the corporation would fork it. He said, fork the code and develop it yourself. Why should I spend my time unpaid to do your job? And then you're making money from it. That's a common pattern in open source projects. Anyway, the next one is also in 2021, so it's a CVE for Log4j. I don't know if you've heard of it. So the Log4Shell, the famous one, it broke literally everything. Why? Because Log4j is used in, do you know any Java software not using Log4j? If you know, please tell me. That's it. That's how it broke everything. And then this is an exploit for JNDI, and it can like do whatever. The next thing, this is also for a Spring Boot. This is a new one, 2022. I think in January. And this, the hacker found the vulnerability in Spring Boot core. And this is the exploit. These are exploits, you know, which I'm going to talk about later. These are problems with supply chain. So this is, if I'm not mistaken, this is Baker.js. At some point, no more free work. I don't want to work for free for you. Why should I? You know, Baker.js is this library to generate fake data for testing. And it was for, you know. And then this one is also another example. This is very recent, last week, I think. The Python CTX problem. So what the author, the hacker did was that the domain was expired. And what he did, he bought the domain, created an email, went to PyP, sent a password reset email, took over the project on PyP, published a new package, and added these 3 pieces of code to the Python package, and voila, you have all the entire internet sending their AWS access keys to your server.
That's so messed up.
That's messed up, and that's an example of supply chain. On the same note, for this Log4j, it was so severe that that's like a lot of our clients in K6 was reaching out to us via customer support, via like all the channels we have, and asking if we are impacted by this vulnerability. And at some point, our CTO just wrote the blog post here and said, okay, we are not using Java. Anyway, like literally. We are not impacted by Log4j. Not us, not our vendors, no one. That's it. Put a pin on that, please.
So, in conclusion,
No. You should definitely use whatever you feel like it, but you should. Okay, I'm gonna say what to do and then what you say. Yeah, it's fine. Okay. It's not a new thing. So NIST. I'm just pressing the wrong button. Sorry. The NIST published this cybersecurity supply chain risk management framework. Sorry, it's a mouthful. NIST-CSRM. It defines this, it's a program and also a framework that defines a set of policies, enterprise-wide and also practical, and also a few practices to help companies mature in cybersecurity supply chain risk management. I just wanted to mention this. I don't want to expand on this topic because that needs its own topic and its own, talk to go into the details. But feel free to check this link. I've already I have all these slides and everything that I'm presenting on my own account on GitHub. So github.com/Mostafa, and then you will probably find this practical system. And yes, so I just wanted to mention this, which later I will go back to.
You have your own name on GitHub. How hard? You must be very early.
2013.
Cool. I mean, there's so many people in the world.
Yes.
My-
Exactly.
Like people.
And yes, okay. I just wanted to present this part a little bit like later than earlier. But then I thought, okay, I'm just presenting something, but then I'm not giving the context. So let's go into a little bit details, more practice, not talking. Stay talking. Okay. We have 4 different stages or 4 different parts in our system. Generally, that's one way to categorize it. I know it looks off, but please bear with me. 4 parts of our system that we can use security tools to detect vulnerabilities, weaknesses in our software, and yeah. So for scanning the code without running it, I can actually point at it. We can use SAST tools. So SAST tools are static application security testing tools. Imagine linters. Have you worked with linters before? Have you linked your code? So the linter doesn't execute your code. It just goes over your code, tries to compile it, but it doesn't execute it. It's not the task of a linter to execute the code, usually. SAST tools are like that. They check the code, and if something is wrong with the code, they detect it and show it to you. They usually look for signatures or patterns, which are already published by CVEs and CWEs and other standards for publishing security vulnerabilities and weaknesses. And yes, they will present the results to you in some form, either through a dashboard, a file, something. You've probably seen it already, like CodeQL from GitHub is an example. Snake is an example. Okay, SIFT is an example. Gripe is an example. These are like SAST. They do not run the code, rather they check the code. That's it. That's SAST. The next one is the components that we use. Especially, I'm talking about open source components or libraries or dependencies, depending on how you want to call them. Okay. And what we do for those components that I'm going to talk about today is we do SCA, software component analysis. So what do we do? Okay, so we have a software. It has a few dependencies, and those dependencies have dependencies. At some point, you have a never-ending black hole of node modules sitting around somewhere on your app, and then you don't know what's happening, and you have 10 versions of one library sitting around somewhere because of a dependency to something that you use from some developer who's, sorry that I say so, lazy enough to not update the dependency. And what happens then? That you become vulnerable to a dependency that you never know exists. That's the problem. That's something that you don't know because you lack visibility into your components. Okay, I also mentioned IAC and containers and stuff because there are two separate ways to do this. So either SRE or programming. So in the SRE practice, you have infrastructure as code. You can also check that. You can do SAST on IAC. And at the same time, you can also check your containers or components in your container. Okay, so you're using a container, like for example, imagine Debian image. It's a standard image officially published by Docker or Docker Hub. Everybody uses it, but nobody looks into it. There are a lot of executables, a lot of paths inside that container that you literally don't have any idea what's going on. If you're not familiar enough with Linux, or you just want to use something that works, yada yada, then those problems happen. At some point, that JavaScript library developer, that something tool developer gets fed up because he or she is not paid, and then will break all the other software that others have written, and we rely on that sort of stuff. On staging, we do dynamic application security testing. These are the sort of tools like OWASP Zap. So you run the code and then you pop up Zap, and you start pausing, you start sending some payloads that are like malicious and stuff. I don't know. There are a lot of software in this category. And also there is IAST, so interactive application security testing, so manual testing, so a hacker goes and tests. And in production, you have cloud and infrastructure tools, so like access management, fine-grained access control, VPN, this and that, all sorts of defensive and sometimes, depending on the cloud provider, offensive tools to test your production environment. Okay. So what is software component analysis? That's not all those 4 slides, previous slides. I was going to talk about this, but then wanted to also categorize things in your mind and also in mine to get to this. So software component analysis is an SAST-like process for identifying the potential areas of risk that I talked about, the risk of using open source libraries and third-party libraries, and also hardware components. So SCA both refers to software and hardware, but for the sake of this talk and practicality reasons, I stick with the software part. For more information, I always put a small link here in this corner, and you can read more about component analysis or software component analysis in this link. So it's all that. So what is the result of this analysis? What does it do? What is the end result? The end result is something called SBOM. It generates a file called SBOM. So you run this tool, which does SCA. We don't know what it does internally. We don't want to know. But at the end, it generates an SBOM and a few other artifacts. So what is an SBOM? What is an SBOM? An SBOM is a kind of a bomb for software or bill of material, a list of all your dependencies that you use in your software. Okay, so what does it contain? Yes, dependencies, our components, our libraries, whatever the developer decided to use is inside the SBOM. If at some point I decided to use like CTX, the Python library, or Log4j, this SCA2, which I'm going to show you, will find it and show it to us, which also I'm going to show you. And then the next thing it contains, by the way, it's just a JSON or XML file. It's a simple file. I'm going to show you quickly. It also can, but not necessarily, contain licenses and copyrights. So that, like, for example, some companies enforce licensing policies. For example, I've heard that Google do not accept AGPL license. So if any of these developers at Google want to use AGPL code, they can't. They have to write their own library. That's it. So if they have an SBOM, they can easily check and just say, okay, this is not qualified.
And that's also good because then you can see if somebody changes the license of an open source library to
something that you should pay for.
Or maybe the exact opposite, like actually new license, that you can't actually pay for it, and now try to get people to pay for it. Then you can see that very clearly. So you have a summary of all the licenses that you're
Exactly. There are a lot of cool things about this that I'm going to talk. At the end, it also contains vulnerability differences that I talked about. So if there is any vulnerability inside any of those dependencies, it will reference those vulnerabilities or weaknesses. And then when you load it in your software, it just shows, okay, this version of the dependency has this known vulnerability. So please upgrade or don't use. Okay, this is the website that this image comes from. This is the internals of SBOM. It contains a lot of things that I'm going to show shortly. Let me see if I can. Yes. Oh, okay. By the way, this is the repository for what I used. These are examples of JSON files, or examples that I used today and show you what they mean. Also, the link to the slides and simple README and a Docker compose file. I can also show you that. Okay, this is SBOM. Okay, this is Cyclonetics. Just want to show you something real quick. This is an example of an SBOM. Can you see it clearly?
Yeah.
Or is it like, should I zoom in? No?
I'm in the front.
Yes. Anyone on the back won't need to zoom in. It's fine. Okay. So this is an SBOM file. It has the, if everything is okay, it has the format of Cyclonetics, which I'm going to show you real quick. It uses the 1.4 version of Cyclonetics, a few other metadata, and then if I scroll down, you see that there is something called components. So if I show you my repository, come on. Okay, this is something I developed. Okay, it's a Go application, Go extension. It doesn't matter. I'm just showing, because then I want to show you what's going on. And then it has a few dependencies here. You see all these dependencies. I use JavaScript VM, Avro for messaging, Schema registry client, JSON, Schema, Kafka Go, Logruns, Testify. Imagine this is a Log4j. And I use the tool to generate this SBOM file. And if you look closely enough, you will see dependencies here. So there is a reference to this package I used, all the details, type of it, name of it, version, scope, hasher, and everything. These are very useful. I'll show you. By the way, let me show you how it's produced. GitHub Action. for building the library. And then at this point, if I zoom a little bit, it's more visible. Okay, I use something called CycloneDX Go Mode, generate JSON, also output licenses, and the output should be this file that I just showed you. Okay, and it's easy to install. Just go install this, and then I can upload the resulting JSON file to the artifact repository of GitHub, or I can upload it to dependency track, which I'm going to show you a little bit further down into this slide. So this is the end. Yes, let's continue. Yes, that was the file.
Just to summarize, it means that if you have these GitHub actions set up, that as soon as you push any changes to your source code, it will automatically regenerate the
Exactly.
things, and you don't have to worry about it manually, and you can prove to anybody that.
Exactly. And okay, how can you use this file? Enterprise corporations and companies, when they sign a contract with you, they require this file. And then they import it in their software and see what they're dealing with. Like, for example, they're acquiring our SaaS or our open source software. And then at some point, they want to see if they become vulnerable to any dependencies that might be introduced to their systems. Like, for example, by using my tool. How can they know? Easily, you just give them the file. As easy as that. I'll show you a little bit. Yeah. So I've already shown you what I've got, so that's that. What is SBOM? I think at this point you have a fair idea of what this SBOM can be used for. But generally, it can be used for inventory. So if you have software containers and everything lying around all over your company, imagine you have like Amazon, you have hundreds of thousands of developers or tens of thousands of developers. Each of them would introduce a new dependency every day into the code. And how do you know this doesn't increase the attack surface of your code or your company or your software? Simply by just integrating this SBOM generation into your pipeline, CI/CD, and then generating them, storing them somewhere, and having some sort of software, which I'm going to show you, just to scan these files and then pop up error messages if anything suspicious happens. That's the whole idea. So I think I already said inventory, identification, and management of supply chain. So what is supply chain? I already said software components, open source software components. What are the risks? Developers not willing to cooperate, some sort of dependency, some hacker found, or whatever happens.
We just a bug that some junior member of the team happened to install and not.
Exactly. There are a lot of risks. So, but generally, the supply chain risks are those risks that you introduce via dependence for the sake of this specific topic. And that's it. Okay, SPDX or CycloneDX. SPDX is created and kind of developed by the Linux Foundation. Some companies require SPDX, especially government organizations. I don't know why. And then there's CycloneDX by the OWASP community. And I personally prefer CycloneDX, and it has a lot of tools to convert between Cyclones and SPDX. I'm not sure what I'm saying is completely correct, but I think CycloneDX ecosystem is more developed than SPDX. Although there are a lot of tooling that generates both, but you haven't heard it. By the way, I'm going to show you real quick something, but if you're interested in more details about this software bill of materials specification, Robert Martin presented this talk at the conference from Mitch, and he goes into every little dark corner of this thing and show you what you need to know. So yes, let's go back to this. Okay, this is CycloneDX website, visible, and then it has a lot of different ways to store those dependencies. So you have SBOM, software as a service, bill of material. You have SBOM, you have OBOM, you have this, you have that, you have a lot of tools. And then there are like the capabilities of SBOM. So these are all the standards it supports, like SBOM, SBOM, VEX is very important. Vulnerability exchange format. It can produce files in XML and JSON or protobuf, and there are other things for different types, like as I said, SaaS software stuff. There are a lot of use cases, as I said, but components it supports to scan. And okay, it doesn't scan, it's in specification. It's a way to describe these things. So there are tools that generate these files. And those tools are tools that can classify those components in your system into these categories. So application, container, device, library, file, firmware, framework, operating system, and service, depending on what you use and what tool you use to generate this file. And then there is this tool center. So there are 129 tools of all different vendors and stuff. There are open source tools, there are proprietary tools, build integration, analysis, GitHub action stuff, transformation for changing between SPDX and CycloneDX and stuff. Libraries to use inside your code to generate these files without using external tools, and a few others. And this is the specification. Yes, this is the specification. I've already shown you this, and yep. And this is also the end result of what's going on. There are a few examples here also, if you want to have a look at different examples of like SBOM, SBOM, or whatever I talked about today. This is also available. So, like for example, if we go to SBOM for Juice Shop, do you know Juice Shop? Juice Shop is a test application for hackers to learn how to hack. Juice Shop, juicy dependencies, which I'm going to show you. And this is the result in both formats. So it's a huge file. I think, yeah. I mean, I scanned it once and it was like 4.4 megabytes file of all the dependencies inside the container. You see Node.js modules, like libraries, everything. You see this licenses.
So what if the license is missing?
Okay, so there are software that you can manually enter it into your.
Okay, in another scenario, what if you have more than one license, multiple license?
It will list all of them.
So how do you ensure which maps in the core license?
Okay, that's I think a legal question rather than a
okay.
Code question. So then it's the legal people who should deal with, can we use this? If we use this, do we have to pay? Are we liable for something? I don't know. And then there's this interesting software or one-page application that you can play with and generate your own SBOMs. Well, that's for sure. And then
store the data as well.
Sorry?
If you just play up, it does store the data as well.
I don't think so. It's just for generating this file. I don't know, honestly. Just go check the privacy policy. Yes. Another tool from Cyclone DX. Also, there is CLI for this, but I just want to show you this one. You can convert between different formats. So, for example, if I have a file from Cyclone DX that I want to convert to SPDX, and then I say what the file is, and then the output, and it will just convert it on the fly for us. Or if I want to validate a file, or merge a few different files generated by different pieces of software into one, you can do it. Or there are like the CLI. It's called Cyclone DX CLI. So that's that. Let me see. Now's the demo. After all these things. Okay.
Is here black hat?
Oh no, it's just a big like okay. At the end, what I wanted to show you. So I already shown you the CI/CD thing and then how to generate this. There are a lot of tools you may know, or like Sift. Have you seen Sift? So it's a CLI tool and library for generating SBOM from container images and file systems. So it's a very famous piece of software from Anchor. And
Can you really trust that though with the applications that you have race conditions? You like file it, right? So different machines will generate things differently, even the same piece of code.
it's not a scanning code, it's scanning dependencies.
Okay, but it's scanning just looking at what dynamically loaded in or static.
It's all static, nothing new.
Yeah, well, some, yeah, that's
But yes, okay, so fair point. I've used this software to scan container images, and when it finds, like, for example, Go application, it also scans the binary and shows the bomb for that.
Go is much different because it actually keeps a lot of the metadata from the
Yes,
language.
yes.
You see that sometimes. So
Honestly, I haven't worked with C in that
Yeah,
specific
yeah.
case, but probably
thinking more if you're
you have a fair
running
point.
see things like, or just a container, right? You have a kind of like things that you don't normally maybe look at, right? That you don't know.
Yes, that's Talk about it. Yeah, exactly. So the thing is, if you when you're scanning your containers, there are a lot of, as he said, C tools, but then those C tools have hashes and versions and file names and stuff that you can match against vulnerabilities. And if something is unknown, then it will say, okay, this is an unknown piece of file in your container. The good thing about Sift is that it is recently been integrated into Docker Desktop. I'm not sure, but yes, Docker. And you can use Docker scan or Docker SBOM. And then it will generate an SBOM from your container for you. Yeah. Yes. Okay. I just shown you my library, the XK6 Kafka extension. It's a Go application, Go extension, application, whatever. Works on top of K6 for load testing Kafka. That's besides the point. There are a lot of dependencies I use, and is indirectly used by K6 that I import, that I have to compile with. And compare it, basically. At the same time, I also recently started generating an official Docker image for my project. And I scanned it, and it generated a file. How did I scan it? Simply, or not so simply, by just going to my, can you see here? Oh, yeah. Okay, let's see if I have Docker. Yes. Docker something. Yes. Just want to show you something. Okay, so for the sake of this demo, I'm gonna scan another image, which is the juice shop from this person. I want the Docker, the latest Docker executable, generated an SBOM for me using SIFT from this container image, the latest version. I want to include all the layers, not the last layer. I want the format to be CycloneDX JSON. So you can specify SPDX and CycloneDX. And I want to output it to this JSON file. There you go. Fingers crossed. Okay, so the SIFT, as you can see here, SIFT version 043 used internally. So it loaded the image, parsed the image, cataloging all the packages that it's used. That's fine. It's because of old versions of CycloneDX, which SIFT cannot compile to because of some issues. But it generated a file for me. So let me see. There you go. If I add this, then yes, we have a file which is 4.4 megabytes. It scans the container for that juice shop project, which is this one. This is juice shop. And it generates extract dependencies from everything and shows you this. Now I'm gonna start. So I think I'm a little bit over time, but they just say
That's fine, as long as we get Tom Jones in there. SBOM, SBOM.
yes. So what I'm gonna do is that I'm gonna start dependency track, which is a continuous SBOM analysis framework or platform. This is open source and it can play over. Yes. To ingest and digest those SBOM files and show you results. Let's see. Let me. This is just a test. Okay. I've already imported. Okay, I added 2 projects. I can add. Like juice shop 2, and then latest version classifier. It's a container, and then create and juice shop 2, and then you go to components, services, dependency graph, audit vulnerabilities, void prediction, and stuff. You can upload the SBOM here. Let me see if I can do this. But anyhow, I just imported it. Just want to show you. So I imported this file here yesterday, and it found 2,230 dependencies inside that container. It found 24 vulnerabilities inside the container by itself. I didn't touch anything. I just imported the file. And some of these are like in this area, which we have to deal with very soon. So the severity and impact is like very hard. You have to fix them like right now, not tomorrow. And then I also imported my own project, so the dependencies. So it found 24 dependencies. You see, it quickly shows if the dependency is outdated. I think that dependent button stuff does the same thing, but then you have a clear view of everything all at the same time. And for the last thing, I want to show you this policy management. I defined the policy. Okay. I said, I do not want any permissive license. Please no. And then for any operator, please warn me if the license group is permissive. Okay. And what happens is that you see violations here. You see violations also here. So if I go to policy violations, so 4 different dependencies inside my container violated this license dependency. And you see the warning. That's what I was talking about. So SBOM, vulnerabilities, and also at the same time, you can triage your vulnerabilities. So for example, you see that there's a critical vulnerability in the busy box in your container image, and it's very critical. It has a CV assigned and stuff. And then you just click, and there's a description, there's an audit trail. You say, okay, I accept the risk or something. TISC, is it something new? And then say it's the analysis, but at some point you find it's exploitable, and you say it's exploitable, or you suppress it, and it won't be checked again. And this is the log of what you did here. And then you can at some point, triage and say, okay, these are exploitable, these are fixed, and then it also has an API. So whenever you generate an SBOM file in your CI, you can just push it to this dependency track, and voila, you get automatic continuous SBOM analysis for free.
Can you also integrate it?
Yes, apps. I suppose so. It supports a lot of analyzers, vulnerability sources, notification, like alerts, webhooks, and then it also integrates with 45 effect version, others. It has access. Yeah, it's a very well matured software. That's it. Thanks for listening.
Last question. How is it different from like white source?
One moment.
Yeah.
No. That's the same thing.
There
Yeah,
is
exactly.
some
Yeah.
time for questions, but maybe we should, so that people can compare as well.
Time for questions.
Maybe 2-3 minutes, like 1-2 questions.
Of course, yeah. How many questions as people want, not as I want, or as people?
And we can
White
also
sources.
continue at the end, like with the.
At the end, we also have a QA.
I mean, we have.
Okay. Maybe. Okay. Yes, white source is also another tool that generates SBOMs. And then there's SIF, there is Gripe, there is Trivy, Snick. Snick also generates SBOM, and can also visualize, show stuff. And anything else? Docker, that's it. There are a lot of tools nowadays. Veracode, Checkmarks. These also support generate. Like for example, I know that Veracode generates its own SBOM format, and then there's the Python tool that converts it to SPDX or cycloidal along the same line. Yes, please.
You mentioned Dependabot. How is this different from Dependabot and like Does it give something more?
No, dependent bot. Okay, dependent bot is a bot to just update your dependencies if there is a vulnerability published. That's it. There's no visibility other than just scanning your dependencies and just suggesting new updates. That's it. Doesn't show you if you are, violating any company policies. It doesn't show you, all the details of your containers and stuff.
So
Dependent
it's a
bot only
broader-
works, I think, I'm not sure. Correct me if I'm wrong. It only works for your dependencies in your project, not your containers. I'm not sure. If you know, please stop. Yes, any other question? No? If there's no other question, please, yes, feel free to go for it.